Today we are looking at absolute value equations. First of all, let's talk about absolute values. Absolute value, when you have these straight bars, that's the absolute value of 4. That means how far is this number from 0? That's 4. Absolute value of 7 is 7. The absolute value of -2, though, is 2. It's a positive 2. And this is going to be a 19. Absolute value is always positive because distance is always positive. And so the distance -2 is from 0 is 2. If I had something like this, the absolute value of -237. Well, that's 237 because -237 is 237 away from 0. That's the distance from 0. So that's what absolute values are. All right, well, suppose I have a variable in there. Like the absolute value of x is 4. What could x be? Well, actually, there's two values. X could be 4. X could be -4. Because the absolute value of 4 is 4, and the absolute value of -4 is 4. Similarly, if I have the absolute value of y is 12, that means y could take on two different values. Y could be 12, or y could be -12. Because the absolute value of 12 is 12, the absolute value of -12 is 12. All right, you got to watch out for something like this. Suppose you have the absolute value of x equals -3. Absolute value is always positive, so if it equals a negative like this, this is not possible. There's no such value that work for that. Okay, here's another example. The absolute value of 2x plus 3 equals 11. All right, this thing inside here could be 11, but that thing inside could also be -11. So we've got to set up two equations for this thing. And I solve each one. So right here, when I solve this one, I'm going to subtract 3 on both sides, and that'll go away. So that means 2x equals 8. And now divide both sides by 2, and it looks like x equals 4 is one solution. If I do this one, I'll subtract 3 on both sides. That will go away. That means 2x equals, that's a -14. Now divide both sides by 2, and x would equal -7. And here's my two values. And a common misconception here is that these are opposites, and they're not. They're not opposites. Depending on what the equation is. Sometimes they are, sometimes they're not. Most times they're not, and that's what we have here. But if I put these in, 2 times 4 is 8. 8 plus 3 is 11. The absolute value of 11 is 11. That one works. If I do -7, 2 times -7 is -14. -14 plus 3 is -11. And the absolute value of -11 is 11. So both answers work. Here's number 1 on our homework today. 9 equals absolute value of x over 11. Now the absolute value is on the right, but it doesn't matter which side it's on. But what I'm going to do is I'm going to write x over 11 equals 9, and then x over 11 equals -9. Here's my two equations. Well, when I solve this, I'm going to multiply both sides by 11. That'll make this cancel, and x equals 99. Here's one solution. Right here, I'm going to multiply both sides by 11 as well to make these cancel. And x would equal -9 times 11 is -99. So here they are opposites again, but they're not always like that. What about this one? Okay, this absolute value equals 22. So that means -2 plus 5y could equal 22. Or -2 plus 5y could equal -22. So we set up two equations for that because this thing could be 22 or it could be -22. I solve both. So right here on this one, I'm going to add 2 to both sides to make this go away. That means 5y equals 24. Divide both sides by 5, and that's 4.8. There's one solution, 4.8. Right here, I'll do the same thing. I'm going to add 2 to both sides. It makes this go away. So 5y equals negative 20. Divide both sides by 5. Y equals negative 4. And here's my two solutions. I can do a calculator and check it real quick. If I try 4.8, okay. So negative 2 plus 5 times 4.8 comes out to be 22, and the absolute value of 22 is 22. If I try negative 4, okay, negative 2 plus 5 times negative 4, and I get negative 22, and the absolute value of negative 22 is 22, and both solutions work. Okay, here's number 9. Now, if you notice on number 9 here, we've got this 1 that's kind of hindering us. So we realize that this absolute value can have two values. And so what I need to do is I need to get that absolute value isolated by himself, which means I need to subtract 1 on both sides first to get rid of this, which gives me this. 12 minus 1 is 11. And there you go. There's my absolute value. And now from there, I set up my two equations. So that means 7 plus 3x equals 11. 7 plus 3x equals negative 11. And there's my two equations. I got to do it from this point. I cannot do it from there. If I do it from here, set up two equations, I will come up with wrong answers. Now from here, I'm going to subtract 7 on both sides. 3x equals 4, and then divide by 3. X equals 4/3, and we'll just leave our answers as fractions unless it tells us to reduce it as a decimal to a certain decimal place. Here I'll subtract 7 on both sides. That'll go away. That's negative 18. And then divide by 3 on both sides, and that gives me a negative 6. And there's my two solutions right there. Okay. Now, if I put them in, I really need to go to this to put it in and make sure it's right. I got to make sure I didn't make a mistake here when I subtract 1, but it's probably best just going right into here. So if I put 4/3 in, so I've got 7 plus 3 times 4/3, and that's 11. So the absolute value of 11 is 11. If I put negative 6 in, 7 plus 3 times negative 6, and that's negative 11. And the absolute value of negative 11 is 11. So they both work. Here's number 10, similar type problem. There's one little catch on this. When I subtract 1 on both sides, there's a negative in front of that absolute value. So I've got to keep that negative in there. And over here, this comes out to be a negative 9. Okay, well, we got a problem here with this negative. We've got to divide both sides by negative 1 to get rid of that negative. When I do that, I've got the absolute value of 4x minus 3, here's my absolute value bars, equals, that's a positive 9. And so now I can set up my two equations. So I've got 4x minus 3 equals 9. Then I have 4x minus 3 equals negative 9. I set up my two equations and solve both. Okay, so here I'm going to add 3 to both sides. So that means 4x equals 12. And then divide by 4. And I'm running out of room here. I get x equals 3. There's one answer. Over here, I'm going to add 3 to both sides. 4x equals negative 6. Divide by 4. And x equals, that simplifies to negative 3/2, or negative 1.5 if it wants a decimal. There it is. Okay. Now, what about number 12? It's a similar type thing as what we just did. See, I've got my absolute value here, and I've got to get this absolute value isolated all by himself, which means this 8 and this 4, both of those have to go. Well, the first thing I do is get rid of the 8. I'm going to minus 8 on both sides, and that 8 minus 8 goes away. Now, this stuff drops down. And over here, that's a negative 16. All right, we're looking good. Now, see this negative 4 in front? I need to divide both sides by negative 4 to make those negative 4s cancel off. When I do that, I've got the absolute value of 8 minus 5y equals, and then that's a positive 4. And here's what I'm striving for. I got to get my absolute value all by himself like this. And now, once I do that, I can set up my two equations. So that means I'm going to have this. I'm going to have 8 minus 5y equals 4. I'm going to have 8 minus 5y equals negative 4. And I solve both of those. So as I solve this one, minus 8 on both sides, negative 5y equals negative 4. Then I divide by negative 5. And that's going to be 4/5, or 0.8. Right here, I'm going to subtract 8 on both sides. That'll go away. Now negative 5y equals negative 12. Then I divide by negative 5. And that's going to be 12 over 5, or that would be 2.4. All right. Now, a couple more. This is number 14. And this one's different because we've got a variable on this other side. Still, though, this absolute value's got to be isolated, and this plus 1 has to go because we've got to have our absolute value all by himself. And in this time it equals 3x minus 1. All right, so now I can set up my two equations because I got my absolute value by itself. Now here's where we're a little bit different this time now. So I've got this 5x minus 7 equals this 3x minus 1. But here's the other one right here. And here's where this is a little different. This 5x minus 7 equals the opposite of this. All right, the opposite of that is going to be a negative 3x and a plus 1. See here, I got 3x, so that's going to be a negative 3x. This is minus 1, so it's going to be plus 1. And this is the opposite of that. And so as we're doing these, this thing inside could be that, or it could be the opposite of that. So I've got to take in consideration this variable and do the opposite like that. Okay, so as I continue on here, I've got variables on both sides. So what I'm going to do is I'm going to have to subtract 3x on both sides to make this go away. And that gives me a 2x minus 7 equals negative 1. Then I'm going to add 7 to both sides. And that's going to give me a 6. And now divide both sides by 2. And x equals 3 is one solution. Okay, on this one, same thing. I'm going to have to get rid of my variable from this side, so I'm going to have to add 3x to make them go away. That's going to give me an 8x minus 7 equals a positive 1. Now I need to add 7 to both sides to make this go away. And that's going to give me 8. 8x equals 8. And now I divide both sides by 8. It looks like x equals 1. So 3 and 1 are my two solutions. Now let's check it in the original problem up here and see if it works out. So first, if I put 3 in, 5 times 3 is 15. 15 minus 7 is 8. The absolute value of 8 is 8. Then I have 8 plus 1, which is 9. Now if I put 3 over here, 3 times 3 is 9, and that works. This answer right here works. What if x equals 1? Well, let's put 1 in the equation. So let's mark this out here. If I put 1 in, 5 times 1 is 5. 5 minus 7 is negative 2. Well, the absolute value of negative 2 is a positive 2. And 2 plus 1 would be 3. Now, if I put 1 in over here, 3 times 1 is 3. And sure enough, this answer works as well. So both answers work. Okay. Just for your benefit, we're going to do another one like that. Okay? Do another one here. So again, we have our absolute value right here, and this plus 3 has to go. So I'm going to minus 3 on both sides to make him go away. So that means this absolute value of 5x minus 6 equals 4x minus 3. These absolute value bars, they didn't get very straight. So now this equals 4x minus 3 and the opposite of 4x minus 3. So 5x minus 6 equals 4x minus 3. Okay, get it on there. And then I got 5x minus 6 equals the opposite of this, which would be negative 4x and plus 3. This is the opposite of that. So I've got this set up to 4x minus 3 and negative 4x plus 3. All right, now I solve both equations. So here, I'm going to have to subtract the 4x on both sides to get this gone. And then just be 1x minus 6 equals negative 3. I'll add the 6 to both sides. And x equals 3 is my solution there. Okay, on this one, I'm going to have to add 4x to get rid of this. So 5x plus 4x is 9x minus 6 equals 3. Well, I'm going to have to add 6 to both sides to get rid of this, and so 9x equals 9. And then divide both sides by 9, and it looks like x equals 1. And there's my solution. So it looks like 3 and 1, the same answers from the previous problem, huh? 3 and 1. All right, well, let's check them. So if I plug them in, if I do 3 first, 5 times 3 is 15. 15 minus 6 is 9. The absolute value of 9 is 9. And 9 plus 3 is 12. So on this side, I get 12. If I put 3 in here, 4 times 3 is 12. And so that works. This answer is right. What about this one? If I put 1 in, so 5 times 1 is 5, minus 6 is negative 1. The absolute value of negative 1 is positive 1. So I've got a positive 1 plus 3, which is 4. So here's my answer as well ago. This time I get a 4. And if I put 1 in here, 4 times 1 is 4. So 4 equals 4, and this answer works too. All right. So I think we're in good shape. That's absolute value equations. And if you have any questions, just let me know. I'll try to help you all I can. Have a good rest of the day.